Hi folks! Our latest tech blog reveals why Inflection Games chose to upgrade to Unreal Engine 5 midway through developing their upcoming fantastical open-world survival game, Nightingale. For more on this, head to unrealengine.com/feed. While you're there, learn more about why Crotium switched from their in-house engine used for 2 decades to UE5 for the Telos Principle 2. Prepare to respawn into a new dinosaur survival experience beyond your wildest dreams with Ark Survival Ascended, and with it, cross-platform modding that you can start using at launch with the new Ark dev kit. Learn more on the Xbox Partner Preview blog. Moving over to this week's Community Spotlights. Face off against rivals and demons in a mysterious world. Use dark magic, acquire powerful weapons, and strategize to survive. Unravel the secrets of the Bornless by Cathedral Studios on the Epic Games Store. Introducing Great Houses of Calderia from Resistance Games, a feudal grand strategy game focusing on family dynamics and stories. Rise the ranks of Calderia, produce, trade, scheme, bribe, and battle to build your legacy of power. Wishlist on Steam. Combining fluid flux, megascans, procedural content generation, metahuman animator, and more, 3D and real-time virtual production Unreal artist Sam Galen showcases the results of their hands-on experience. Let them know what you think of the wizard over on their art station. Thanks for watching this week's news and Community Spotlight.
Hello. Hi, hello everybody. My name is Arjan Brussee. I'm head of product management on Unreal Engine, part of the dev team, and I'm going to talk to you about Unreal Engine 5 in its broadest terms. So there's going to be a lot of things I'm going to cover, so bear with me. It's going to be quite intense in terms of detail. And we'll follow up with some we don't have time for Q&A, but there will be a link to the roadmap that you can check out and look at more things that I'm talking about. So yeah, today I'm going to talk to you about where Unreal Engine 5 came from, right? Where the ideas came from and what we got to so far, right? We're going to touch on just released 5.3 version, lift a bit of the curtain on the future releases that are coming, right? The future things that are in the pipeline. And, you know, as a disclaimer, right, we generally want to under-promise and over-deliver, right? And we're now going to show some of the things that are very much in development. So, you know, we don't have hard timelines, right? It's software development. We're doing some of the hardest things in the industry, so you know we'll update you on the feasibility and the timelines when we have better insights. But yeah, this is just like the forward-looking stuff as well. So yeah, the journey so far. You know, it all started with this first prototype we did back in 2020 called Lumen in the Land of Nanite, right? That really showed what was possible if you made like a next generation renderer. Right, and you know, we did this as a tech demo, you know, prior even to the release of UE5, right? And this showcased really this unbounded detail and complexity alongside with real-time GI that could do realistic dynamic lighting and dynamic worlds without baking. Then 1 year later, we went to a UE5 early access and showed off the capabilities with the latest demo and the early access release. So there, a lot of time was spent on workflows, right? Improving the workflows on role partition, 1 file per actor, data layers, right? Quixel workflows, and further performance enhancements to kind of make all this detail kind of sing. Then at the end of 2021, we shipped the Matrix Awakens demo, right? Which really showed the capabilities to render large-scale photorealistic cities and for the first time. But also includes high-end quality characters, high-end animation, post-processing, those kind of things. You know, this was built with a procedurally generated city, you know, built in Houdini, because we found, right, with its previous demos that we couldn't just hand place all this level of detail anymore, right? We needed smarter tools, better tools to create these large worlds. So then, right, part of this productization of all these features, we shipped it in Fortnite, right? And the big thing there was, take a game that was basically UE4, right, in terms of assets, and kind of upres it to UE5 and add kind of all these new features at performance, right, running at 60 frames per second, but also having fallback options for previous gen platforms, right? And this was all shipped with 5.1. And then, right, last GDC, we took this procedural thing that we tested with really the Matrix demo, and we took that to the next level with Electric Dreams, right? And this was a system that we actually built inside the engine, so we could do much faster round tripping. We didn't have this import-export kind of flow of like going from the external DCC to internal, and you could see what you were doing right in the viewport, etc. And that's alongside with this foliage sample that finally showed us some non-rocky and non-stone-based worlds in a demo. So yeah, that's the journey. You all know that. But if you look at all these things, then you can see the pillars, right, of UE5. Right, these are all the areas we've been developing towards for UE5, and this is like the true line of the UE5 generation, right? So all these things have been released in some state of functionality, but some of them are also not done, right? These are things that we will keep on building on for future releases. And also based on the feedback we're getting from all you, right, that are using the technology. So, it is also a dynamic plan, right? So we will keep spinning up new areas where we see the need, right? But these are a good overview of all the areas. So yeah, let's go through some of the new things, right? Recent and new things. So I'd like to kind of go over like the aims, right? Like what we're aiming to do with these technologies, and then kind of go into 5.3 and then kind of go into future. Rendering, right? It's pretty straightforward, right? You want to be state-of-the-art rendering, at performance, right? 60 hertz on consoles is really the goal for this kind of level of fidelity, while also having fallback for older hardware and also other platforms that can't run this kind of level of GO. We also want to support high-end photorealism for all these other industries, right? Like Unreal is used everywhere, right? From film, VFX, architecture, product visualization, and such things. So for that, right, we have a lot of things in flight, and also with the reference path tracer support that the renderer has. 5.3. Bunch of improvements, some cool stuff. Nanite with programmable raster is now able to render masked and textures in WPO much faster, right? We have some quality improvements with normals and all that. Lumen gets a bunch of things, exciting. For instance, Lumen reflections can now be run on next to like baked lighting, so you don't have to run the entire Nanite of Lumen pipeline if you don't want that or need that for your game. Orthographic rendering is exciting for many use cases. Volumetrics got a big update, right? We're looking at things like you can now transform cached fluid sims and instantiate them at different locations and time to get much more complex effects out of a single kind of cached sim. Also having that supported in path tracer, right, for like these offline things, and generally fluid sims and supporting sparse volume textures are now much more able to store volumetrics in lower memory and higher performance. Path tracer got a bunch of improvements, especially regarding initial support for substrate materials, so you can use those complex materials for like automotive type things and kind of render them with path tracer, as well as support for smoke, fire, clouds, like heterogeneous volumes there. While we're on substrate, still experimental in 5.3. We say like it should not be used for production yet, but we encourage testing it and giving us feedback, right? And UE5 includes many improvements there to performance and capability and stability, but again, right, it's not production ready yet. Yeah, so going forward, right? First thing, we really want to keep hammering performance, right? So performance at complex scenes, right? Like complex high-definition scenes on modern consoles, needs to hit 60, right? So we have work ahead of us to constantly kind of keep improving that, and while able to increase the fidelity. Really exciting is to see tessellation and displacement coming down the line. So that's very close, right? Probably 5.4. That you can start seeing that. A great way to add detail cheaply on simple base geometry by just entering displacement maps, right? Also we have nanite spline meshes almost ready. So that will be, extruding static meshes, deforming along the shape of a spline, right? Useful for roads and such things, right? Very, very clear use cases. And, substrate, right, to the next level. With substrate, right, like in many of our features, we really want to, prove that also in our own games, right? And before we can call it production ready. So, we want to get substrate in Fortnite at some point and have it run without performance decrease, right? And then, call it kind of ready for general consumption. Last but not least, we have open development and R&D into foliage, right? Foliage right now at the fidelity levels that we'd like to see, right, are not maybe fast enough, right? So, we have to look at nanite, we have to look at lumen, we have to look at shadow solutions to really kind of get super detailed dense forests that are moving and all that, and render those efficiently. It's a really hard problem. We don't have the solutions yet, so it's probably going to take a bit longer than certainly the next version, but it's an active R&D. So yeah, world building, right? So one of these other pillars, right? Big pillar in UE5, right? We want to really be able to create large worlds much more efficiently and effectively with UE, offering better workflows, workflow creation improvements with like 1 file per actor, world partition, data layers, level instances, such things, but also handle the streaming of content seamlessly, right? So we're using these technologies internally at all our projects alongside with many licensees. So it's not a early technology in that sense anymore because it's being used at scale, really. But yeah, the goal is that we really want to aim for huge worlds, right? And we're saying like, well, you have to pick a number, 16 by 16 kilometers with millions of actors, right? And that means that to hit this kind of number of, this extra order, multiple orders of magnitude, more objects, we need to work on performance across the board, right? It is things like adding objects to the physics world, lightweight instances, further streaming improvements, all those things. So big things there. With world building in 5.3, some exciting things. First of all, nanite landscape meshes. So the landscape can now be rendered using nanite, also greatly accelerate the rendering of shadows and the landscape in general. Right, you have large landscape import and export, so you can now use the world partition tooling to import really huge worlds into sections into your world. So that's that allows that kind of stuff. And for instance, like level streaming persistence as well is a plugin that we're doing that manages saving and restoring of specific properties of objects when levels are streamed in and out. So very useful. Going to the future, right? Many things, right, are still on the list. And all these things we want to use to improve workflows, customization, quality, performance in general, right? And at any world scale and density. Some of the workflows are, new world partition hash that's coming that will allow for like 3D grids instead of like the 2D grid that we have now, and also make it easy to implement your own streaming solutions for your project, right? If you have some other kind of layout you want to go for. Workflow things like HLD and editor, right? You can now create and see those things in the editor, great. We have this new system called one file per actor, right? We are seeing that with some of these super dense things, especially with procedural generated worlds, where you see like tens of thousands of objects, that's coming a bit of a bottleneck again. So we are now introducing one file, many actors, so we can store the PCG content all created into single files to help with the file churn and the perforce and source control nastiness that happens otherwise. Another kind of big thing is a next generation terrain system. So we have ambitious plan towards what we call like landscape 2.0. That's in really early development, right? That will take some time, right? But the idea is that we want to get the fidelity of landscapes to the same level as nanite is in normal placed objects. And there's a lot of research that needs to be done until that time. But we do have the ability to kind of extend our current landscape with like higher fidelity and potentially displacement coming in shortly with the nanite landscape. So hopefully that's kind of an interim step while we develop the new terrain system, the new landscape 2.0. And all this stuff needs to work efficiently and scale to all these huge worlds. So the procedural content generation framework, right? We're really excited about that tool, right? It was showcased at GDC. It's really about this building large world pillar, right? So how can we build these worlds without having to hand place everything and relying on external tools and seeing it all in the viewport and iterate on these parameters. It's also really interesting, and I keep repeating that, is it's a runtime system. It can run at runtime. It can even generate LODs at runtime. So you can have gameplay that affects the world and the placement of objects in the world by using this system. So that's a really powerful thing. We hope to see some cool things come out of that from licensees. And obviously this can also be used for linear content creation, right? If you want to make movie sets or backgrounds for your product visualization and all that, these are kind of cool systems to use. So with 5.3, we have some initial work on like a hierarchical generation system that will distribute the graph execution at different grid sizes and share the results between LOD levels. So you can make things like high detail up close, low detail far away. We have external data processing, so you can now import Alembic point clouds, and that replaces our by now unsupported city sample rule processor that we shipped with the Matrix demo. So and now with the benefits of PCG on top of that importer, right? So it's a better way to interoperate with something like Houdini plus PCG, kind of a hybrid setup. And a lot of usability things, right? People are using this stuff, giving us feedback, and we're improving that while we go. Future of this, right? It's a lot of cool things in flight. What we want to do is work on the runtime hierarchical generation, so they can actually run inside the executable itself and generate all these LODs inside the game itself. We are aiming to get GPU compute and microscattering to work, so you can have like super fine detail up close, like running on the GPU completely. Allow for more graph execution, so you can kind of figure out like where at what point is the logic running, right? Is it running on certain threads? Is it running on CPU, GPU, or what's the difference between various platforms in terms of the detail level that you're aiming for? Many workflows. I think also a really interesting thing we're looking at is like we have this huge Quixel database of all these super complex assets. But what we want to do is make these assets like smart. So the Quixel assets have built-in smart rules, like using the PCG. So a tree knows that it can only grow on like a certain slope and not on a rock, and it will spawn bushes under the tree or maybe not in the shadow, right? So you have like all these kind of complex systems that you can now build and distribute with our Quixel library, and that will be distributed through Fab, right? So that will hopefully greatly accelerate building these worlds with this kind of content, right? So we're going to extend all our Quixel type things into like smart procedural systems. yeah, we are targeting beta ready for production at around 2024 with our continual development. So a lot of work is ongoing. So good things. Pretty short term. Next topic, animation. Large goal we have is to push for this fully animation authoring pipeline, right? But bypassing the need for most content development to rely on these external DCCs. This obviously helps for round tripping, right? You don't have to import, export, and it will increase the iteration time. We also unlock the ability for people to animate in context, right? They can animate in the final pixels. They can animate, while the lighting is on the character, while the character's in shadows, etc. So this is a really new superpower for animators. So the animators that are embracing this see huge increases in efficiency and all that. It's also a flexible and extensible framework that you can be extending on with using Python and plugins, and hopefully we'll see marketplace plugins come in that really extend the tool set even further, right? And then last but not least, we want to make it easier to use, right? So right now it's maybe hard, but so we want to see more people become animators and effective in using these tools to create animations and create this kind of stuff. So yeah, 5.3, big new thing is the skeletal editor. It allows you to create skeletons and edit the skin weights directly in the Unreal editor. Obviously, again, you don't need to go back to this external tool. It also means that you can easily add bones to any asset and put the weights on and deform static meshes without having to kind of do that workflow through an external tool. So again, that's a big improvement in time. Animation edit authoring inside the editor has gotten a large number of improvements. Right, you have things like smart baking of keyframes, a better curve editor with better usability and performance, showing motion blending while you're doing root motion preview, those kind of things. And then, right, we're going on to control rig, a huge amount of excitement about that, right? We're seeing now ways how to use external data that drives control rigs and that can procedurally create and modify the control rigs, right? But also kind of throw export control rig animations back out with FBX export support. ML Deformer now has a bunch of improvements where it's much easier to set up this training data while in the editor, so you don't need to go outside of the editor and see the results in the editor. And we've also released some of our training data from the GDC recently to do the really advanced muscle sims in external tools. So yeah, future. Animation and engine is a huge push, right? So internally, we have most of our animators at Epic starting to use or already using these tools in Anger, right? So we're getting a lot of feedback from them, right? We're constantly iterating on the workflows and the feedback we're getting. So these tools are getting really much faster, fast. 5.4 release, which we say is a GDC release, GDC 24. Is going to see a massive leap again in animation functionality across the board, right? On the runtime and gameplay quality, we have been working on motion matching for a long time, right? And we now have that in active production with our internal projects, where we combine it with layering and really get some really good results out of that. So that will now be more ready for people to use going forward. We also plan to ship example data sets and debugging tools alongside with this system, so it's more easy to kind of roll it out and see what's actually happening and why it's choosing certain animations or not. On our high performance bullet point, that is a kind of new unified animation pipeline that we're building. It's a longer lasting initiative where we aim to replace the animation graph logic by logic running on a rig VM. So it can be much faster, but it will also unify the control rig and the animation composition into a single framework. So with this system, we will run our next generation animation logic, and that will completely remove the need for animation blueprints and also remove the need, which is our goal, to have to nativize animation blueprints in C++ if you need to get the performance out when you're finally shipping the game. So no more nativization needed. Control rig, we're working on like making it much more modular, so it's more like a ability to kind of kit bash character parts with rigs together into new characters, and a ability to kind of deploy these control rigs as like modular parts that you can attach to your characters and all that. We also have the ability to kind of layer this, right? So you can layer control rigs on top of, like, for instance, incoming motion capture data or other animation data, and that can really help accelerate kind of general animation workflows, which is really, really new and exciting. Then, another thing is the deformer graph framework. Sorry, that it allows you to add these real-time deformation systems on top of existing Unreal meshes and get to that level of fidelity. Sequencer, we bunch of things in flight. Maybe a good thing to talk about is the ability to extend the existing behaviors to support like dynamic user-defined things coming into the sequence. So it allows you to make better interactive cinematic experiences instead of just the pre-baked things that don't have any relationship with what the game is actually doing at that very moment. So yeah, animation, a lot of things. So yeah, going forward, framework, right, for which we say is gameplay, AI, networking. That's that group doing all that, right, where the aims are to really democratize the creation of these framework systems and realize a great tool set for building these complex worlds, right? Complex AAA and large open world type things because they're pushing kind of the complexity furthest, right? We want to get there by improving performance, obviously a lot, but also helping improvements in workflow and scalability and efficiency. So with 5.3, we now have smart objects that support world partition, which is great. It works seamlessly with world partition data layers, persistent levels, and it also has been improved to support nav mesh and physics to determine slot reachability and such things. We have a long requested blueprint merge tool, which is only available for data assets at the start, but we aim to have that ready for general data-only blueprints in general in the near future. Stage 3, we have now a debugger for it, and it has expanded kind of breakpoint and general debugging capabilities. Yeah, so future on framework, many things obviously in the pipe. Maybe some interesting things to talk about. Nav mesh and nav link to support huge open worlds and world partition even more in the flight. Instance actors and mass, right? That's a approach where we take improvements to the mass framework to convert mass entities to actors and vice versa at runtime to support a far greater number of objects, right? So objects close are maybe full-on actors and components, but they can collapse into simpler mass entities when they're further away and vice versa. So it allows you to make crowds and large crowd sims and such things. Mover 2.0 has been in progress for a long time. It's getting close now. It's a container from the many new movement modes, and we are spearheading it with a new physics-based network mover component. Then we have Iris, and Iris is our new replication system that's been in flight for some time. It's going to be much more efficient, especially on like dedicated servers, and it will move to the next stage of readiness when we have proven it in our internal projects shortly. The gameplay abilities framework, right, a fan favorite, right, is getting some good love, where we are modularizing this over multiple plugins, which allows us to simplify these workflows for users, but also reduce memory usage upfront. And then we have support for smart objects that also allow for player interactions and make these interactions actually client-side predicted, so you can use smart objects in multiplayer games. So that's also really exciting. Yeah, then moving on to simulation. So simulation, obviously a core part in making believable living worlds, right? And it's also core to building more photorealistic digital humans and VFX for both real-time and VFX and such use cases. And we're using machine learning approaches to ensure these technologies can be applied in real time, right? It's a kind of an optimization type approach. So with the simulation team, we've been pushing on all these areas for a long time, and it's really about features. It's about interop with other simulation systems like Claude, VFX, Niagara, gameplay, but as well as constantly aiming for performance, right? And we're going to use performance a lot in this slide. In 5.3, we have improvements, big improvements in Niagara fluid dynamics, where you can now bake them, and general performance has been improved there. We have the new Chaos panel cloth editor that allow you to make cloth and do better skin weight transfer algorithms, and also use our new XBBD constraint system to get like much more high fidelity cloth out of it, where you can make a trade-off in like speed and quality setup going forward for like even better looking simulations. And that panel cloth editor will also work together with ML deformer editor, so you can do it inside the editor and see the results of the training in live. So yeah, lastly with 5.3, general performance updates with destruction, rigid body, and scene query aspects of the chaos physics. So yeah, future, many things in flight. One of the interesting things is we're working on this replication model improvements to scale to like large-scale networked physics worlds, right? Where you're kind of simulating a more complex, physically driven world and sync it to all the clients efficiently. Exciting to see that we now have a visual debugger in flight that is actually starting to work really well, and that helps you debug the state of their physics world and see where the performance are, see what things are sleeping or not. So that's in progress. Just showing videos, it's actually working. We have a new vehicle system where it focuses on more like plug and play components of physics that you can add to any vehicle, right? So you can't only make simple vehicles, but you can make much more than just cars, for instance. That new character mover with the physics-driven motion is in flight and will be shown soon. Many ML learning improvements for Claude and Flash that are in flight, and general performance. But especially things like when we scale to these next order of magnitudes, more detailed worlds, right? We start to find bottlenecks in many systems, including things like adding to physics world and such. So there's work there that's on the table. Then my own personal favorite is developer iteration, where we have a lot of efforts underway for quite some time now to help reduce the iteration times, right, and get that into a much better cycle. Obviously, right, this faster iteration mean more iterations in an hour means you can get to better quality in a given amount of time. So it's not just efficiency, but it's also quality that you'll reach with your experiences. So with 5.3, we now have multi-process cook in beta, which will help greatly to increase cook performance on single machines, right? On build farms or build servers or on your own machine, right? In Fortnite, we see 2-3 times performance increases in cooking using this. So it's well worth enabling that and seeing if it works for your use cases as well. Then we have virtual assets that are now production ready. If you haven't looked at it, that's really interesting for especially like distributed teams, where if you're using Perforce version control and a shared Unreal DCC, you can actually stream the metadata of the objects and the bulk data kind of separately, which will greatly increase sync speeds for people that don't need the source assets for all the things, right, that are in your depository. So yeah, beyond 5.3, a lot of further work on cooking, right? Like today we have what we call like iterative cooking, right? So every time, right, we have to refine all the things that are changing, and moving forward, we are optimizing the cook process to also handle incremental changes to configs and code to avoid recooking the same data. Then we have target platform iteration workflow enhancements, where we can use like a new local DCC and a cooked output store and stream that to the console, for instance, via the network, which will greatly increase iteration speed instead of like copying files over to the platform. Async loading for editor and for cook processes will, across many threads, will greatly increase performance for editor load times of big worlds, but also play in editor and also the cook side of things. And then cooked editor, right? This is a request that we see a lot, especially since we've released UE event that's using this kind of paradigm. This is kind of longer term, probably beyond 2024. It's modeled on the learnings of UE event, but we have a lot of work to do to kind of make it engine ready capability. But yeah, there's interesting workflows where people, if they sync to a version of the editor that's built on the build farm, why not also sync the cooked assets so that they don't have to locally cook things and convert things, and it will generally accelerate people's workflows that way. So yeah, then going on to the content pipeline, their aims there is that we want Unreal Engine not to be a walled garden, right? That's a huge thing. So our goal is to allow importing of data into UE and UE event, but also export of data from UE event, and all that through standard formats, right? So that's the direction we wanna take there. So to do some of these things, right, we have this new interchange framework that we are introducing in 5.3. That's kind of a new system that replaces the legacy import factories, and it's like a modular and customizable pipeline. So there you can now import things like GLTF and OBJ, as well as all texture formats are now running through that pipeline. And UE 5.3 also has this support for like importing and re-importing entire scenes using like USD scenes and such things. We have support for Material X in USD experimental. There's also improvements around materials and textures in general. You can do like multiple UV sets, but also have basic animation support to support more of these virtual production use cases that people are obviously using. And then we have like Tessellator to use for like a CAD type level importing. Beyond, we want to have FBX import run on interchange, so that's coming production ready shortly. We are looking at porting all our existing enterprise tools like Datasmith over to the interchange thing, so that it can benefit from the new capabilities. And then, we want to use Material X shaders and support those in Substrate, for instance, and those things. So yeah, modeling tools, right? Again, this is one of these things where we are building new tools and workflows for creators, designers, technical artists right into the editor. And this will help increase round-tripping times, as well as it's like an extendable and customizable tool chain that you can build up yourself for your own use cases. So with 5.3, a bunch of improvements, many things on like workflow, in UX with like new UI, a better selection first workflow, which has been a long-standing effect. We have like custom presets for tools as a new workflow. As a new tool itself, we have a new spline tool generator that allows you to make a new draw spline and revolve tool to kind of make more complex extruded things along a spline. And these tools will get a lot of enhancements going forward as well. And then we have like new display of UV maps and distortions and texel density type things, also kind of workflow things in the overall geometry pipeline. So yeah, going forward, a lot of further workflow improvements will constantly happen, right? We obviously have some catch up to do, but they're getting enhanced every day. Exciting to see is that we now have improved gizmos in the pipeline that will really help, make the interactions between UE type editing modes and external DCC tools editing modes more common. For instance, right, we're looking at a new arcball gizmo or indirect manipulation type gizmos. So this is really making the whole editing of objects a bit more modern compared to other tools. So yeah, then platform, right? So obviously Unreal runs on everything that has a GPU. And we want to allow you to make content that scales across all these platforms. With that, right, a lot of things in flight, a lot of things with 5.3 on mobile, right, where we have like runtime, virtual texturing support, instance rendering improvements, fog volumes, all exciting. Nanite is now able to run on M2, so you can run it on your MacBook type class hardware, which is cool. We also have worked on better Xcode project setups and all that to make it more consistent with how Xcode workflows work in general. And that allows you to do also like the iOS simulator that's on the Apple Silicon to allow for faster dev iteration without having to run on the device and being able to kind of debug that easier as well. Then on XR, a bunch of improvements. So Nanite can now be configured as like a single pass when we select the instant stereo rendering option. So that's an improvement in speed. Lumen can now use view coherency between the two frames to kind of accelerate the Lumen resolve, which is great. And then we have eye-tracked image generation with OpenXR, reducing the amount of total pixels shaded, right? The foveated ERS type stuff. So yeah, then going forward, right, we do want to allow or get the desktop deferred renderer on high-end mobile, right? That doesn't mean it's Nanite and Lumen, but it means that it's the desktop deferred renderer, right? So it's like PlayStation 4 level functionality in some ways. And we are also looking at ever improving the in-editor previews, so you can see the result of final pixels if you select a specific type of hardware and don't have to kind of look at it on the platforms itself all the times. Yeah, last but not least, next-gen audio system, right? That's another pillar of UE5. We've been expanding this feature set for some time now, and 5.3 is probably our biggest release since MetaSounds was launched in 5.3. So with 5.3, we now have MetaSound output watching, which is a way to enable Blueprint or C++ to watch for changes in the MetaSounds graph and to match gameplay and visuals together with what's happening in the MetaSounds. With the Builder API, you can now get faster iteration times where users can script and automate the creation of MetaSound assets kind of automatically. Audio bus riding means you can now link all these MetaSounds together and create new MetaSounds by linking them, but also kind of streamlining all that stuff together. Going into the future, we have audio insights, which will now enable creators to intuitively debug and profile CPU memory usage when you're optimizing your project and looking at sounds. General performance improvements there and workflow improvements to make like configurable nodes and such things. So yeah, a lot of work going on there. So yeah, that's kind of in a fast view all the things that are in flight. We have this roadmap site, right? We always called it the roadmap, but we only showed the kind of the upcoming release, which was just a month out or something. But now we are extending it to show like a future-looking roadmap. So I'm really excited to announce that this is now live, right? Since Monday, this is live. Scan the QR code, unrealengine.com/roadmap, and you see a lot of our future-facing stuff. Obviously, the next question is like, when are these things available? Because I want them now, and why do I have to wait for it, and all that. So, bear with us, right? This is a kind of a big mind shift change for us already. What we want to do is make this an evergreen thing. What we want to do is make it's clear when things are ready for 5.4, and we want to commit to it in a certain release. We will move it to the 5.4 session much in advance, so you can see what's coming, right? We don't want to be a black box, right? We want to have open development. You can already look at our GitHub and see all the typing going on by all our smart people on all these new systems. But now, right, you can see the cards and the descriptions of these things. And this is an interactive tool, so you can type feedback, right? So we're reading the feedback. It's going to be really useful for us to get this feedback on these future features to validate our approach. And that's it. Thank you so much.